Lesson 8.2 is related relates. I don't know why I keep saying that. Related rates, but this time I have triangles instead of rectangles. Tells us a right triangle has legs of 15 inches and 20 inches, whose sides are changing according to time. The short leg is decreasing by 5 inches per second, and the long leg is growing at 9 inches per second. What is the rate of change of the area? So I'm going to kind of work backwards here and think, okay, well, area of a triangle is the formula 1/2 times base times height. And they tell me a short leg and a long leg. Pick one of them to be your base and one to be your height. Let's just say this is the B and this is the H. Okay, and so this is also to me the short leg and this is the long leg. Okay, we just have to be able to set everything up so that we know. Okay, short leg then. So I'm going to put, since that's B, I'm going to put dB to time is decreasing, so -5 inches per second. The long leg, or H, so DH to DT, is growing at 9 inches per second. What is the rate of change of the area? So now I need to take, because my end goal is having dA to dt. Take the derivative of a formula that connects everything together with respect to time. So that would be dA to dt. I'm going to do a times right here. So that would be keep 1/2 a B times the derivative of H, which would be a 1, but times dH to dt, plus, and then I'm going to have H times the derivative of 1/2 B, which is, let's see, just 1/2, because that's my coefficient, right? 1/2, but then times dB over dt. So I'll put a 1/2 in front. Sorry, that's so small. And then I'm ready to plug everything in. So we've got 1/2 times base, which just my base was 15, times how is the height changing according to time, which is right here, that's 9, plus another 1/2 times height, which is the 20, times how is the base changing according to time, -5. And so then that would be 15 times 9, I'll just divide by 2, 20 times -5 would be -100. -100, half of that would be 50, so that would be 17.5. So this triangle has its area increasing of 17.5 squared inches per second as your answer. All right, number 2. A right triangle has legs, whoa, that got bad, sorry, of 33 and 44 inches long. I don't know, in my picture this is the longer one. It doesn't matter where we put them. The short leg is decreasing by 5 inches per second. Long leg is shrinking at 3 inches per second. What is the rate of change of the hypotenuse? So this time I have nothing to do with area. So using area formula gives me nothing. Hypotenuse of a right triangle has to do with Pythagorean theorem, which is a squared plus b squared equals c squared. So this is technically my C. This, I don't know, I'll just call this A, and this B. It's your choice. And then in terms of the problem, I'll call this the short leg and this the long leg. Okay? And so it says the short leg, which is my A, according to time, is decreasing at -5 inches per second. And that the long leg is shrinking, so that's my B, at 3 inches per second. All right, I want to take the derivative with respect to time of this. So derivative of a squared would be a 2a times a dA over dt, plus b squared would be 2b times dB over dt, equals 2c times dc over dt. And you should be knowing that when it says what is the rate of change of the hypotenuse, we're finding dc over dt, the hypotenuse to time. Okay, so I have something to plug in for A, right? That's 33. I have something to plug in for how A is changing compared to time. That's -5. I have my B. I have how B is changing with respect to time. I've got to write smaller. 2 times, I don't have a C. So how can I get just what C is in this triangle? Do Pythagorean theorem right now. So that would be 33 squared plus 44 squared equals C squared. Square root that. So C is 55. So I kind of just start, and then if I see I'm missing something, then I find it. And then times dc over dt. Okay, so I got 2 times 33 times -5. 2 times 44 times -3, -264. 2 times 55 would be 110 times the dc over dt. -330 minus 264 is -594. And then I'm going to divide away the 110. All right, so then we found out that the hypotenuse is changing with respect to time of -5.4, just inches per second, because this is not like an area. It's just a measurement, would be your final answer. So it depends on if they're telling you what's the rate of change of the hypotenuse, then you have to use Pythagorean theorem as your formula. If it's the area, then you have to use area of a triangle as your formula.